25 years ago, this bathroom was brand new. Today, with cracks in the ceiling, mold in the shower, and a barely working sink, it was time for a change. We are building what might be the smartest bathroom ever, pulling in tech from around the world, no compromises on hardware, no ecosystem lock-in, and no budget constraints. Everything runs through Homey Pro by Adam, letting us combine the absolute best tech in the world, no matter the brand, protocol, or age. From cutting-edge systems to old-school infrared gear, it all works seamlessly together. But first, we had to pick up some gear in order to tear it down, and subscribe if you want a full Ryobi setup and review. We are dropping that soon. Now the real work began. We stripped the bathroom completely back. Mirrors, shower glasses, fixtures, everything visible came out first. Then the pipes were removed and we started breaking into the tiled walls. This was decades of construction being undone layer by layer. Everything hidden behind these surfaces was finally exposed. Without taking any shortcuts, we are going to rebuild everything properly from scratch. Then the toilet came out and we disconnected the drain from the waterproofing layer, but as we started lifting the membrane, something didn't add up. This bathroom had been renovated before, but not properly stripped. Beneath the first layer, we found another floor, all tiles, concrete, and a second waterproofing membrane still left behind. From there, we took down the remaining walls until all that's left was the wooden frame.
No shortcuts now. We go all the way, no turning back.
Then the floorboards came up, revealing pudging clay underneath, an old-school insulation method used in houses like this. We documented the original 4 square meter bathroom, designed the new 9 square meter layout, and worked with an engineer to calculate exactly how the load would be distributed. To carry the load, we installed massive glue lamp beams, but to keep the floor perfectly level with the rest of the house, we had to recess them into the structure. After all the planning, the beams finally arrived and we began installing them, locking everything into position with added crossbeam support. And to get the square drains perfectly centered, we added extra beams to create an even layout across the entire floor. And in the end, everything was carried by a 120 by 120 millimeter steel beam anchored straight into the foundation. We've also put together a full breakdown of all the costs involved in the renovation. Link is in the description. As you enter, the washing machine and toilet sit on the left with a sink on the right. Further in, you have dual showers on both sides, leading to a centered bathtub as the focal point. With the layout locked in, the plumber came in and we started running all the in-floor piping. We installed supply lines to the right side shower and sink. For drainage, we used Geberit Silent Pro to reduce the noise from the running water and insulated the entire floor with rock-wool sound plates. For the supply system, we went with Sonipex, and yes, it might look like a lot, but that's because the setup will have multiple smaller outlets. And while the piping inside the bathroom is impressive on its own, the supply line actually runs out of the room, down through the first floor, and then all the way across the basement before finally reaching the home's water heating system. Before we could run the piping on the left side, the walls had to come down first, and that's when we found something unexpected: a large brick wall sitting on a single weak beam. It honestly shouldn't have held up, and we're lucky it didn't fail earlier. After removing the walls, we installed moisture-resistant particle boards, glued and screwed down before starting the framing. Each shower is controlled by one of 2 electronic valves, each with 6 outputs. One handles the right side and the other handles the left, and also feeds the bathtub. Everything else, the sink, toilet, steam generator, and washing machine, runs off a separate manifold to keep the pressure consistent. With the plan in place, we started unboxing the fixtures. All of the shower components and the toilet are from Kohler, and the first thing to go in was the in-wall tank and carrier. Next, we connected the toilet waste pipe to a small technical room behind the bathroom, where all the drainage lines come together before continuing down through the house. Once the waste pipes were in, we moved on to the Sonipex supply lines for the left side of the bathroom. This included 3 additional lines for ceiling fixtures, as well as 2 main supply lines feeding the underfloor heating distribution system. To finish off the left side, we installed an additional waste pipe for the washing machine. We then added timber support for the body jets, as well as the hand and overhead showers. Using a laser, we marked out the exact mounting points before installing dorm-bracked elbows. These will serve as the connection points for all the shower fixtures. We also marked mounting points for the DTV Plus control screens that will be used to operate the shower. Since each shower will have 6 body jets, we split them across the valve outputs, 3 jets per outlet to increase available pressure. To keep the pressure consistent across all jets, we built a pressure loop, and for this section, we switched from Sonipex to Gerbert Mepla since its rigid piping is better suited for this kind of installation, where a pipe-in-pipe system doesn't offer much benefit. We then connected the Sonipex lines to both the Mepla loops and the remaining shower fixtures on each side of the bathroom. To connect the shower fixtures to the dorm-brack elbows, we needed BSP to NPT adapters, but since Kohler uses US threads and we're working with European standards, nothing off the shelves would fit. In the end, we sourced the right adapters from an oil rig supplier where mixed standards like this are more common. We capped off the elbows and covered them for protection. Then we set up a temporary manifold and pressurized the system using a garden hose to make sure everything could hold the pressure for a few weeks while we still had easy access. While the system was under pressure, we moved on to installing all the electrical cables and wall boxes. We ran into another US standard issue with the Kohler steam generator. It is 220 volts but rated for 60 Hz instead of our 50 Hz supply. To ensure safe operation, we had to upgrade the circuit capacity, including increasing the breakers from 220 volts 45 amps to 60 amps. Since Sonipex can't handle the temperatures from the steam generator, we switched to copper, running brazed pipes from the bathroom to the unit. Another challenge when running steam is that the ventilation systems are triggered and releasing the steam out. So we fixed it with Schneider power tags. When the steam generator kicks in, our smart home platform Homey detects the load and automatically shuts off the ventilation and closes the duct. And if you're curious about the oversized breaker panel, subscribe. We got a full video coming on our home data center that heats both the house and the pool. Back in the bathroom, we sealed all gaps at floor level before installing masterboard. In Norway, fireproof material is required beneath electrical heating cables, so this step is essential. We then added reinforcement mesh, giving us mounting points for both the electrical heating cables and the water-based heating pipes, as the bathroom floor actually uses 2 separate heating systems. We started by running all the water pipes from the central distribution unit and routing them through the floor to the rest of the house. Then we laid the bathroom heating circuit, starting near the windows where heat loss is the highest, before looping through the entire room and back to the distribution unit. We then installed a load-bearing beam beneath the bathroom window while we still had access. With the beams and piping complete, it was time for the electrician to step in and install the electrical heating cables. He first tested the cables to ensure everything was within spec. We then added a second layer of reinforcement mesh to separate the water pipes from the electrical cables before rolling out the cables and securing everything in place. We then installed a perimeter insulation strip around the entire bathroom, and after that, we measured the height to calculate how much concrete we needed before mixing the Weber cement screed to a very dry consistency. We leveled the floor across the bathroom, making sure there is no air pockets underneath, while maintaining the correct slope so water flows properly towards the drain. Once the concrete had cured, the plumber returned to install the sink drain and the Sonipex wall outlets. Next, we measured where to mount the faucet and soap dispenser to ensure it met its required sensor distance to the sink. Since it's motion activated, getting this right is essential to avoid frustrated users. After cleaning up, we replaced the old wooden windows with PVC, mainly to handle the moisture in the shower area and avoid issues that we had before. In the ceiling, we planned for 2 Kohler rain showers and 2 Foco Litora hi-fi speakers. To keep the room vapor tight, we built 4 sealed backboxes using membrane panels so any steam escaping around the fixtures can't get behind the vapor barrier. We then installed the Kohler Realrain panels and connected the Sonipex lines to their copper fittings. We followed the same process for the Kohler Laminar ceiling bathtub filler. To ensure rigid walls and flexible mounting points, we installed timber backing boards throughout the bathroom. All openings for fixtures were cut out along with insulation around the steam pipe. We then prepared the mounting hardware and started installing the Vedi vapor panels in the ceiling, cutting openings for downlights and routing cables to each position. We used Vedi vapor throughout the walls and ceiling as it's one of the approved systems for steam showers in Norway. For the floor, we used Ardex SK100 Tricom with sealing collars, since Ardex is the only approved membrane within the Vedi system. During the build, a crack appeared in the concrete floor. It turned out we hadn't used a primer between the masterboard and the screed, so the board absorbed the moisture from the mix and weakened it. After consulting Weber, we repaired it by using Ardex P10 2-component adhesive reinforced with metal rails. As an extra measure, we filled in any minor cracks and added a new concrete layer on top. Around the porous tile drains, we used a dedicated Ardex membrane, sealing it directly to the drain flange. We also installed Ardex pipe seals for all penetrations, then sealed the wall-to-floor junctions. After that, we applied Ardex 8+9, rolled out the foil membrane across the entire floor, and finished with multiple layers of 8+9 to complete the system. We acclimated the Vedi vapor panels before installing them on the walls and cutting out all required openings. In the ceiling, we cut a larger opening for the ventilation duct. To quickly remove large amount of steam, we installed a System Air K125 EC fan controlled via Shelve 0 to 10 volt controller. We also added Belimo actuator to open and close the duct automatically. Combined with Homey and Schneider power tags, the entire system is fully automated, adjusting ventilation based on usage without any manual input. Another challenge was a 450 kilo LED backlit stone wall in the shower zone. We had to raise the panel off the floor to reduce the risk of water ingress while maintaining proper spacing between the membrane, LED panel, and the 2 cm thick stone. We cut a 2 cm recess into the timber structure, creating a mechanical stop to prevent the stone from sliding outward. We then marked out the position of the wall divider between the washing machine and the toilet. This wall also houses a hidden handscrew toilet brush and paper holder built into the structure, so proper sealing around the membrane was critical. Then the plumber came back and we checked and planned for the pipe sleeves for the body jets and overhead showers. We then sealed all joints between the Vedi vapor panels using Ardex SK12 tape, including all mounting points. Before installing the pipe seals, we cut out the plastic insert for the body jets to make room for the NPT to BSP adapters. We tightened everything, tested the connections, and then sealed it with membrane. Similarly, we sealed all electrical boxes and downlight openings using sealing collars, bringing the total to over 60 throughout the bathroom. For lighting, we used IP65 rated fireproof downlights fitted with Philips Hue GU10 bulbs. We placed 2 by the bathtub filler to highlight the water, 3 by the Realrain showers, and additional lights for the toilet, sink, bench, and 1 central light for the main floor area. The electrician then terminated the cables to the downlight drivers, leaving the enclosure until after the membrane work was done. In the technical room behind the shower, all cables were terminated before being routed down to the main breaker panel. We now had an almost steam-ready room, just a few more seals before it was ready for tiling. We went with 120 by 60 centimeters tiles, and because of their size, we mapped out every layout in advance to make sure no seams would interfere with the body jets or other fixtures. Once the layout was finalized, we started tiling the bathroom, including the drains. At the same time, the electrician installed electrical heating in the shelf above the washing machine. This was embedded in the tile adhesive before tiling, keeping towels warm at all times. We then tiled the walls, cutting openings for all fixtures and making angle cuts where needed. We completed the look with Ardex G10 grout in anthracite, giving the entire bathroom a clean, cohesive finish. Then it was time to mount the DTV Plus screen bracket and install the screen, connecting it to the network. Using a laser, we found the center and mounted the bracket for the Kohler Smart Toilet controller. While the speakers were IP65 rated, we also needed to protect the wiring from steam. We used heat shrink connectors to seal the connections, then add an extra layer of heat shrink for additional protection. Next, the plumber measured the distance from the dorm rack elbows to the body jets positions, accounting for the adapters. We then cut the arm arms to length, insert them into the adapters, and secure the body jets using Kohler's dedicated tool. Then we seal the water and soap dispenser with silicone before installing the shower slide bar with integrated water supply. We drilled the mounting holes, installed the adapter, mounted the slide bar, and finished it off with the end caps and hose. Proceeded once again, and done. What should have been a simple step connecting the drain pipe to the Kohler toilet turned out to be anything but easy. After some serious trial and error and a bit of online research, we finally got it fitted and brought it into the bathroom. Oh, did I mention it was an $11,000 toilet and now it's in pieces. The first one arrived damaged in the shipping, so we had to order a second. Luckily, this one made it all the way and was finally installed successfully. Since the ceiling was just membrane board, we applied Arctic's F5 exterior filler to create a smooth, even surface, then primed it and finished with 2-component Mapai epoxy paint. On the right side, we also planned a hidden LED strip. We use an IP65 rated BTF WS2805 addressable strip connected to a Gladupto B-LED controller installed in an aluminum profile and recessed into the ceiling. The speaker was then connected, mounted in the ceiling, and finished with a matte black spray-painted grille. For the backlit wall, we ordered custom IP65 rated LED panels with both warm and cold white circuits using Epistar's diodes known for their longevity. Each diode is wired in parallel, so a single failure won't affect the rest. The panel also had multiple connection points, allowing power to be shared across the system. Reliability was critical since everything sits behind a 450-kilo stone wall that is not easily accessible. We started by planning the full layout before gluing them in place. Thanks to the parallel wiring, we could also cut openings wherever needed. Once installed, we had to evaluate the power distribution. The connectors use relatively thin wires, so the more panels in a circuit, the higher the load on the first connection point. With 8 40 watts panels and power fed from the center, that meant up to 160 watts passing through a single connector, well beyond its rating. We then counted the number of diodes on each panels and grouped them into balanced zones, placing higher loads closer to the power feed and lighter loads further away. Each panel was interconnected with its neighbor to distribute the load and improve redundancy. Before connecting everything, we applied contact protection inside the connectors. We then tested each group of panels to ensure everything worked as expected. After that, we planned 2 power injection points per group, placing them near the most central panels to distribute the load evenly. This required splitting each supply wire, soldering the connection, sealing them with waterproof compound, and finishing with heat shrink for protection. We then added silicone spacers around the panels to maintain a consistent gap between the LED panels and the stone wall. On the other end, we installed 6 Gladupto Zigbee controllers to integrate the lighting with Philips Hue. We then tested all the zones together to check for any issues before moving on. The blue stone wall and white bench were made from small pieces of natural stone assembled into a large slab. Leftover material was ground into fine dust to fill any gaps, creating a seamless surface. The slabs were then polished, cut to size, and polished again before being reinforced with a glass backing, resulting in the final product. After receiving the wall slabs and bench, we planned the mounting strategy, adding smaller slabs around the window and coordinating with all parties to safely install a 450-kilo stone structure. The key challenges were ensuring structural stability while maintaining removability, managing transitions to tile, and cutting a near full-width window opening with minimal remaining support. No one we knew and no one we could find online had done anything like this before, so we were completely on our own. After settling on a strategy, we brought one of the stone panels inside using suction cups. Before making the real cut, we built a full mock-up to test everything and verify the dimensions. We even turned the bathroom into a makeshift pool to keep the cut fully cooled and built a perfectly level support to avoid any stress in the stone. The biggest challenge was the material itself. The 5mm stone layer behaves very differently from the 50mm glass backing. A cut that works for one doesn't work for the other, making the risk of cracking extremely high. With the best diamond blade we could get, we made the first cuts. The tension was high all day because this was a moment everyone had been worried about. The first corner went perfectly, but when we moved on to the window cut, we realized the glass backing had cracked in several places. The stone, however, was still holding together, and after consulting with the factory, we decided to continue. To keep it stable during lifting, we hot glued aluminum support rails to the slab. We then lifted it into place, secured it temporarily, and used a heat gun to remove the rails. Then came the second slab, the most critical one. With the window spanning almost the entire width, there was barely any support on one side, putting the stone under significant stress. We took it even slower, more water, smaller passes, and careful corner cuts to get the window angles right. Cracks appeared in the glass backing again, and after consulting the factory, we injected 2-component epoxy into the cracks before proceeding. We then lifted it into place. Once installed, the slabs were held by the tension from the sidewall, supported by the ceiling profile and adhesive around the edges, locking it securely in place. We now moved on to the bench. We bolted it multiple points to ensure that the floating structure could handle the load. After installing the bench frame, we measured and positioned our smart mirror. It was custom made from art forma to fit the space, 160 by 80 centimeters. We went with dual color lighting, a black frame, a 10.5-inch Samsung display with Google Assistant, a magnifying mirror with LED, and a built-in demister, all customized during ordering. A couple of days later, it arrived securely packaged with all accessories. We tested it, connected the screen to our Google account, and installed a Chromecast app to enable video casting as a part of our Homey automations. We then measured and drilled the mounting points, connected the power, and hung it in place. Perfect. Next, we installed the LED panels in the bench frame. We first drilled an opening for the sink drain, then glued the panels to the metal frame to keep them securely in place. The wiring was routed underneath the bench and out of the room to a Glidepto Zigbee controller compatible with Philips Hue. We then made the same cut as the stone slab as in the LED panel and placed it on top of the frame. The final step was installing the drain and mounting the sink onto the slab. The sink is made from the same natural stone as the backlit wall, assembled from smaller pieces with all gaps filled, then ground and polished into a smooth, seamless finish. Next delivery was our Lusso Stone Picasso bathtub. At 140 kilo, it had to be carried all the way up and into the bathroom along with our LG Washtower. Once all the heavy pieces were in, we installed the door frame and door. We assembled the frame, ran the cables, added the covers, then lifted the door into place and secured it. Then we shifted the focus to the windows, installing motorized outdoor zip screens. We mounted them from the outside and connected each one to a Shelve controller for full Homey integration. In the technical room, we installed the Kohler DTV Plus 6 outlet valves that control the shower. Each unit contains 6 electronic valves that can open and close independently with an integrated temperature mixture at the front. There's also a smaller 3-outlet version, but for this setup we opted for 2 6-outlet valves. Each valve is supplied by its own 20mm hot and cold Sonipec lines from the basement with a dedicated hot water circulation loop. This circulation loop is also connected to the hot water manifold for the sink, alongside a separate cold water manifold supplying the toilet, sink, washing machine, and steam generator. At the bottom of the membrane box, we added an Ajax water detector that triggers an audible alarm, sends push notifications, alerts the alarm company, and shuts off the water if any leak is detected. We've also built a Homey app for Ajax, unlocking advanced automations when the alarm triggers. Check it out along with our Schneider and Kohler DTV Plus apps in the Homey App Store. Here is a controller linking the steam generator to the DTV Plus system. Next is the main control unit, a Kohler Connect box for smart home integration, an audio amplifier with Bluetooth and aux, a Z-Wave lighting controller, and a light relay, which we couldn't use due to the US Z-Wave frequencies and voltage differences. Next are 6 Glidepto Zigbee controllers managing the LED wall, each paired with its own dedicated 450 watts mean-well power supply. On the opposite side of the bathroom, we installed a second technical box due to the distance. From here, we can supply power to the Aquara FB2 radar inside the bathroom, as well as the LED panel in the bench connected to a Glidepto controller and a mean-well power supply. For the ceiling LED strip, we use a dedicated tracer power supply feeding a Gladepto WLED controller, which runs all the way up to the strip. The faucet is connected to a small motorized valve controlled by the sensor in the faucet itself. From there, water loops back into the bathroom to the mixing valve in the bench before returning to the sound effects distribution box supplying hot and cold water from below the floor. We also have 3 boxes, each with its own Shelve controller controlling one of the zip screens. Next is the soap dispenser, controlled by the same sensor in the faucet and easily refilled from behind the wall. From the bathroom side, simply placing your hands underneath dispenses soap or water. Under the bench, we installed a Aquara radar sensor that detects presence, even when standing still, unlike traditional motion sensors. Next, we have hot and cold supply lines coming from the wall, feeding into a distributor, soon to be replaced by a thermostat integrated into the bench before returning to the faucet. We also routed power from the Gladepto controller through the frame to one of the 3 LED panels. Lastly, we used a compact wall-mounted bottle trap, keeping it as low profile as possible so it stays hidden beneath the bench. The final step was removing the protective film from the DTV Plus screens and the Veil toilet and installing our Fibaro Wally smart socket and controller. These integrate with Homey, allowing us to monitor energy usage, adjust colors based on consumption or price, and trigger automations directly from the buttons. For more advanced control, we added Rhythm Switch Pro. It connects to Homey and other devices, letting us trigger scenes like raising or lowering the screens, adjusting floor temperature, play music from Spotify, select speakers and playlist, and control both light groups and individual lights. The LG Washtower has its own app for managing programs and monitoring usage, but it's the Homey integration that really makes it smart. It is a combined washer and dryer in one unit using a heat pump for high energy efficiency. The Artforma mirror has side controls for powering the screen and adjusting the volume. In the center, touch buttons control the lighting, tap it to turn it on and off, and hold it to adjust the color temperature. There's also a built-in defog function that heats the mirror to prevent condensation. The Kohler Veil toilet goes even further. In addition to the touch controller, it supports touchless and automatic flushing, bowl pre-rinse, auto open the lid, front and rear wash with adjustable temperature, pressure and massage functions, electrolyzed water rinsing, air dryer, deodorizer, heated seat, night light, and an integrated odor trap fan with filter. For the drain, we used porous towel insert to keep it completely hidden, similar to how the Handskrua Extra Stories conceals the toilet brush, and above the washing machine we add another shelf with 2 discrete black boxes for accessories designed to stay almost invisible. And above that, an Ajax Fire Protect 2 smoke detector, hidden from view but capable of triggering audible alarms alerting the security company, and together with Homey, even cutting the power to the bathroom and activating all showers. Behind the ventilation is a Shelve temperature and humidity sensor that monitors conditions and adjusts fan speed automatically. And hidden between 2 downlights, we also installed a small temperature sensor for the steam generator. For the window, even though it's PVC, the black finish gives it a modern, premium look. From the outside, it retains the classic white glossy finish, but that's completely hidden from the inside. And here is the stone wall, and you can see it shift from warm white to cool white. We typically run it at 50-50 mix and only around 10% power to reduce the load on the LEDs. By overdimensioning the system, we can run it at a low output, reducing stress on the diodes and significantly increasing their lifespan. We usually go with leaf-X strips like in our previous video, but this time we switched things up and ran with WLED, an open source LED controller pre-installed on Gladepto hardware. The advantage is flexibility. WLED gives you far more advanced effects and control, and with Homey Pro we run hue lights and WLED together, combining hue's reliability and range of fixtures with WLED's dynamic LED strip effects, all in one unified system. From the Kohler DTV Plus screen, we can control music, steam, lighting, and even the shower itself. The Kohler DTV Plus is controlled through a web interface where you normally choose from predefined spa modes, but those require a very specific plumbing and fixtures. Instead, we went fully custom. From there, we can create user presets, control how each outlet behaves, set icons, define temperatures, handle purging, and even program the massage sequence. Inside the interface, we can also rearrange the touch screen layout, check connectivity, and fine-tune everything from speakers and lighting to Steam settings, plus monitor all the system hardware in one place. On the right side, we have the Kohler water towel body jets designed to cover most of your body. On the left, the Kohler statement round body sprays focus on a more targeted massage-like experience. In the ceiling, we also installed the Kohler Laminar bathtub filler using laminar flow to create smooth parallel streams of water without turbulence. Next is the Kohler Realrain designed to mimic natural rainfall. It combines nozzles of different sizes with a reservoir above the ceiling, allowing water to fall naturally instead of being forced out under pressure. It also features a deluge mode where the press of a button, the entire reservoir is released over you for a full 30 seconds. The overhead shower supports 3 modes: a massage setting similar to the body jets, a mist mode that combines water and air, and a standard spray. The same modes are also available on the hand shower. The door uses PDLC film sandwiched between 2 glass panels. In its default state, the crystals are scattered, giving it a frosted appearance. When 48 volts is applied, the crystals align, making the glass fully transparent. Using a Shelve relay, we control when that happens, allowing Homey to switch the glass back to opaque when the radar detects someone's inside. Our next project is building the smartest living room we can imagine. A hidden JBL Synthesis sound wall, multi-screen setup, and a fully integrated smart home tech. Subscribe so you don't miss it.
Paper tight when the door lock seals the frame. Every angle calculated, nothing built the same. Hidden valves in the walls, hidden no names. Silent pressure in the pipes when I say engage. Ceiling opens up rain, that's a sky, not a line. Every drop synchronized, hitting dead on time. 17 different modes just to alter my mind. From a warm, slow drift to a storm by design. Screen slide down, outside fades, vision blurred. LEDs, breathing patterns, every pulse observed. Steam dry stick, let the silence get heard. Temperature obeys every coded word. Seal me in steam, let it fall from the sky. Rain hit heavy, yeah, I feel it collide. Shot my system clean, let the pressure apply. I don't step in the wash, I step into a line. Seal me in steam, seal me out of the noise. Every mode engineered just to heighten the choice. Not a room, not a spa, not a flex, not a toy. This is control and design, yeah, perfected poise. Body jets hit the spine in a rhythm precise. Massage map to the muscle, every hit feels right. Towels warm on the shelf, steady heat, no dice. Never guessing the temp, every setting exact. Gemstone walls glowing soft, let the daylight bend. Nature filtered through tech where the circuits send. Steam wrap slow round the room, let the stress suspend. I don't leave feeling clean, I ascend. Touch screen glass in the shower, mirror same cold. One brain, run the system, every function exposed. Lights, rain, bath, sound all in one. No one tap, whole environment go. Seal me in steam, let it fall from the sky. Rain hit heavy, yeah, I feel it collide. Shock my system clean, let the pressure apply. I don't step in the wash, I step into a line. Seal me in steam, seal me out of the noise. Every mode engineered just to heighten the choice. Not a room, not a spa, not a flex, not a toy. This is control and design, yeah, yeah. Perfected poise. Kohler veil, smart dome, future in porcelain white. Silent flush, soft glow, everything polite. Heated mirror, stay clear, never fogs my sight. Alexa, hear me whisper, system wakes on sight. Homey, run the backbone, house moves when I move. Steam lock tight, light slide, music find the groove. This ain't smart home hype, this is something proved. Every wall in the room fully tuned. Seal me in steam, let it fall from the sky. Rain like gravity tuned just to hit me right.